Have you ever wondered how computers perform complex calculations so quickly? The secret lies in the intricate dance of binary numbers, manipulated by assembly language instructions. Today, we're going to focus on two of these instructions, shift and rotate. These operations are fundamental to understanding how computers process data at the most basic level. Shift and rotate instructions twirl and slide the bits of binary numbers, changing their positions. Imagine a line of dancers, moving left or right, or even rotating in a circle. That's what these instructions do, but with binary digits instead of dancers. The most common shift instructions are shift left, shift right, and arithmetic shift right, while the rotate instructions include rotate left through carry, rotate right through carry, rotate left, and rotate right. Each has a unique way of manipulating the bits, leading to different outcomes. Intrigued? Well, hold on as we dive deeper into each of these instructions. Scene script. Let's begin with shift instructions. Just like shifting gears in a car, shift instructions change the position of binary digits or bits within a number. The direction of the shift, left or right, determines how the bits move. First up is the shift left, or SHL, sometimes known as cell. This technique pushes the bits of the destination operand to the left. The gaps left behind on the right are filled with zeros. Picture it like pushing beads along a string. They move to the left, and the empty spaces they leave behind are filled with zeros. An example in assembly language would be SHL AX1, which shifts the contents of register AX one bit to the left. Next, we have shift right, or SHR. This is a mirror image of SHL moving the bits to the right instead of the left. The empty spaces left on the left are filled based on the sign bit for sign numbers. 0 is used for positive numbers and 1 for negative numbers. For instance, SHR CX2 shifts the contents of register CX 2 bits to the right. The third shift instruction is arithmetic shift right, or SR. This is similar to SHR, but it's specifically for sign numbers. The sign bit is shifted in on the left, preserving the sign of the number. An example of this would be SRBX3, which performs an arithmetic shift right of the contents of register BX by 3 bits. These shift instructions are not just theoretical concepts. They have very practical applications in assembly language programming. They are commonly used for bit manipulation, such as extracting or setting specific bits in a binary number. Shifting can also be used to perform multiplication and division by powers of 2 efficiently. In addition, these operations play a critical role in data encryption and decryption in cryptographic algorithms. They are also essential for bitwise logical operations and manipulation of flags. Now that we understand shift instructions, it's time to rotate. Ready to rotate? Here we go. Now rotating is a bit like shifting, but with a twist, literally. The bits are not just moved to the left or right, but they circle around like a bit carousel, if you will. Let's start with rotate left through carry, or RCL. What RCL does is it rotates the bits of the destination operand to the left through the carry flag. Imagine a conveyor belt moving left, with the carry flag being the last bit in line. An example in assembly would be RCL DL1. This means we're rotating the contents of register DL one bit to the left through the carry flag. Next, we have rotate right through carry, or RCR. It's like RCL, but in the opposite direction. The bits are rotated to the right through the carry flag, with the carry flag being the first in line. An example would be RCR SI2, which rotates the contents of register SI2 bits to the right through the carry flag. Now let's talk about rotate left, or RL. This instruction rotates the bits of the destination operand to the left. The carry flag is shifted into the least significant bit, and the original most significant bit is shifted into the carry flag. Think of it as a circular shift to the left. An example in assembly would be ROL X1. We're rotating the contents of register AX one bit to the left. Finally, we have rotate right, or ROR. It's like ROL, but the bits are rotated to the right. The carry flag is shifted into the most significant bit, and the original least significant bit is shifted into the carry flag. An assembly example would be ROR BX3, rotating the contents of register BX 3 bits to the right. These rotate instructions are vital for various use cases, including bitwise operations, data encryption, and even bit manipulation. They allow us to perform complex tasks with simplicity and efficiency, making them invaluable tools in the programmer's kit. Feeling dizzy yet? Don't worry, we're just getting started. But where do we use these instructions, you may ask? Well, the use cases for shift and rotate instructions are vast and varied. They are pivotal in several areas of programming and computer operations, contributing significantly to the efficiency and speed of calculations. One of the primary uses of these instructions is in bit manipulation. Shift and rotate instructions allow us to extract or set specific bits within a binary number. This becomes particularly useful when we need to manipulate data at a granular level, in scenarios such as decoding information from file formats or network protocols. Next, let's talk about multiplication and division. Shifting bits to the left essentially multiplies a binary number by 2, while shifting to the right divides it by 2. This is a much more efficient process than traditional multiplication or division, especially when dealing with large numbers or performing these operations repetitively. Data encryption, a cornerstone of modern cybersecurity, also heavily relies on these instructions. Shift and rotate operations are often used in cryptographic algorithms for both encrypting and decrypting data. They help scramble the data into an unreadable format, only to be deciphered again with the correct key. Moreover, shift and rotate instructions are essential for bitwise logical operations and manipulation of flags. They allow us to perform complex operations on individual bits within a binary number, which is crucial in many areas, from error detection and correction in data transmission to image processing. In summary, shift and rotate instructions are far from being just theoretical concepts. They are practical tools, used daily in a myriad of applications, from the fundamental operations of your computer's processor to the security protocols that keep your online data safe. These instructions are powerful, but remember, with great power comes great responsibility. Use them wisely, always being mindful of their potential impact on your data, especially when dealing with signed numbers and potential overflow. As you can see, these instructions have wide-ranging applications. And that's just the tip of the iceberg. There's a lot more to learn and discover about the fascinating world of shift and rotate instructions. Before we wrap up, here are a few guidelines and precautions. When it comes to shift and rotate instructions, it's not just about knowing how they work. It's also about understanding the potential pitfalls and how to navigate them. So, let's dive in. First off, be extra cautious when you're dealing with signed numbers. Remember, the sign bit is the highest bit in a signed number. So, when you're shifting, consider what happens to this bit. For example, if you're shifting right, the sign bit gets replicated, preserving the sign right. But what about when you're shifting left? The sign bit gets shifted out, potentially changing the sign of your number. So always keep an eye on that sign bit. Next, let's talk about overflow. Overflow occurs when the result of an operation can't fit into the destination operand. And when you're shifting or rotating, you're moving bits around, which can easily lead to overflow. This is particularly crucial when the size of your destination operand is limited. So be mindful of this and plan your operations accordingly to avoid any unexpected surprises. Now, on to conditional instructions. These are your SHL, SHR, and SR instructions. These instructions are conditional based on the specific requirements of your operation. For example, if you're working with sign numbers and want to preserve the sign, you'll want to use SAR instead of SHR. Always choose the right tool for the job. In essence, shift and rotate instructions are incredibly powerful tools in assembly language programming. But like all powerful tools, they need to be handled with care. They're here to make your life easier, not harder. So, always consider the sign bit, watch out for overflow, and use conditional instructions when necessary. Remember, with great power comes great responsibility. Use these instructions wisely. So, we've covered a lot today. From exploring the intricacies of shift instructions such as shift left, shift right, and arithmetic shift right, to delving into the realm of rotate instructions with rotate left through carry, rotate right through carry, rotate left, and rotate right. We've learnt how these operations are fundamental to assembly language programming, manipulating binary numbers by shifting and rotating bits. We also dived into the various use cases, understanding how shift and rotate instructions are used for bit manipulation, multiplication and division by powers of 2, data encryption, and bitwise operations. And of course, let's not forget the guidelines and precautions we discussed, from being careful with signed numbers to avoiding overflow and the prudent use of conditional instructions. Congratulations! You're now well equipped to manipulate bits like a pro. Until next time, happy coding!